This is topic 7 in Unit 1, histograms. So one thing that you may notice is that this topic is a lot shorter than the rest of the topics, and this is because histograms is considered to be somewhat of a review topic. Furthermore, in this topic, we're going to be making the histograms by hand. However, as we go on in the future, we will be using Stata software in order to make our histograms. So that being said, there's two types of histograms that we're going to be making, and they correlate exactly to our two types of frequency distributions that we had made in the previous topic. So a frequency histogram is a bar graph. Again, the bars are going to be equal lengths, and they cannot have any gaps between each other. So these are criteria that we talked about for histograms in the graphing topic. It is the most common graph that you will start with whenever you have quantitative data. The horizontal scale is going to be your classes, so the quantitative values that you have broken down, and they're typically labeled with their class boundaries and midpoints. One note that I want to make about this is that the class boundaries and midpoints are the technical way that they should be labeled. However, I don't think that this is the best way to label them so that your graph is easiest to read. So I will mention this in the upcoming slides. The vertical scale for a frequency histogram is going to represent their frequencies or in counts. A relative frequency histogram is basically the same thing except for on the vertical axis you're going to use percentages instead of your counts. So it is exactly the same as the frequency and relative frequency distributions that we had looked at. So here are some sample histograms. The one on the left is a regular frequency histogram because on the vertical axis we have just the counts, the frequencies. The right graph is a relative frequency histogram because on the vertical axis we have the relative frequency. One note is that you can label the relative frequencies as either a decimal or a percentage. There is a technical reason why you may see the decimal versions more often, but either one will work. Typically, percentages are easier for the regular person to read and understand because they're not smaller decimal values, usually numbers in between 0 and 100. People can read and understand a lot more easily than smaller decimals. One of the most important reasons why we want to make a histogram is that it will give us an idea as to the shape of our data. This is the most important characteristic that you want to retain when you are creating a graph. We're going to talk about two different ways that you can describe the shape of data. However, there are many, many different shapes that you can describe. Some of them are kind of already defined shapes, and sometimes it's just no pattern whatsoever. But overall, getting the idea of the shape of your data is extremely important, and it will be the best way to get an idea of what your data looks like. So the first way is normally distributed data. It's important to understand that it's not normal in the traditional sense. Normal just refers to the specific shape of the data. You may already know this as the bell curve. So specifically with the bell curve, frequencies or the histogram is going to start low. It's going to increase to one or two maximums and then decrease back down. It's also going to be approximately symmetrical. So again, if it follows these two characteristics, we are going to consider it as normally distributed data, and you may also have heard of this as the bell shape. Here are two examples of normally distributed data. The left histogram is just a regular old histogram. I excluded labels because I actually didn't want that to be a part of your thought process. In general, the frequencies begin low, they increase to a maximum peak, and then they decrease back down. And so there is this kind of oddball here, but that's okay. When we are describing the shape of data, we are not usually expecting a very perfect shape. We're just describing in general what it looks like. So anytime that we want to formally state that something is normally distributed, we would actually run a test. So that's something that we're going to be looking at the end of this unit, and then we will formally be testing later on in units 4 and 5. So an important thing to note as you look from this histogram on the left to the one on the right is that when the bell curve shape actually comes about, what you want to imagine is that the histogram gets classes that are smaller and smaller and smaller. So they're divided up. So instead of the class width being 10, it gets smaller until it's eventually, in theory, 0.000001, super insanely small number. Eventually, it will get to a point where your histogram will be almost smooth along the top. So this is a pretty good example of a realistic histogram that could occur that could give you an idea of what a curve would look like if it was placed along the top. So the next way we're going to be talking about data is skewed. And this is a case where you have a bell shape-ish, so it's kind of normally distributed, but it's heavier on one side or the other, or a lot of times people think about that there's a tail. So tail is actually a word that's going to be mentioned a lot. It seems kind of strange, but we will talk about the tail of a graph pretty frequently. So skewed data first, is the histogram will not be symmetric and it will extend more to one side than the other. The graph is considered skewed right or positively skewed. I'm always going to refer to it as skewed right and skewed left though. They will be skewed right if they have a longer tail to the right. The histogram is skewed left if the tail extends to the left. So when you talk about the skewedness of a graph, you are essentially talking about in which direction do you have that little tail. So let's look at some examples for this. So again, imagine that this solid yellow figure was a histogram that the classes got so small that it was a smooth curve along the top. So you never want to forget that this eventually, or previously, was a histogram. So again, the skew focuses on where your tail is. So in this case, this is going to be skewed right. We have the normal distribution, that bell curve kind of hump, and then we have some leftover to the right. On the opposite end of things, if the tail is to the left end and you've got the big hump to the side of it, then this is going to be considered skewed left. One thing that I think students struggle with is deciding whether or not it's, skewed enough to be skewed, or, if it's normal enough and symmetrical enough to actually be normally distributed. And what I tell students at this point is that being able to describe something like that comes from a lot of experience. And at this point, you may not have seen a lot of graphs. So the best thing at this point is to decide what you think, your gut instinct, and I'll always ask you to put a description. So describe why you think it's normally distributed, or describe why you think it's skewed left or to the right. And from there, I can usually say, your thinking is correct, or, maybe you need to maybe make a little bit of a modification. Usually I find that students tend to be a little bit more strict than I would be personally. But I've also seen a lot of graphs, and a lot of graphs that we look at do tend to be a little bit more bell-shaped and symmetrical. But one thing that's super cool is that it is amazing how data in the real world is normally distributed. How much data is the bell-shaped. And we'll talk about that more specifically pretty soon. So let's make a histogram. So this is the data from the previous topic, and this was test scores from a math class. And this is the frequency distribution as well as the relative frequency that we had come up with for this data. So I would pause here and take a moment to, by hands, make a frequency and a relative frequency histogram. I wouldn't go ahead. If you need some guidance, I would actually go and look at the first histograms that we saw on this slide. So I truly did want you to make these by hand, so I made them by hand as well. Traditionally, we would want software to make these graphs because if you wanted to hand something like this into a boss or for an assignment, you would want them to be professional and computer made. However, at this point, it is extremely important that you understand exactly how histograms are made. So one of my policies is that I really want my students to earn the right to the software that we use. So I don't want you to just, put in data and have your computer software do everything for you. I want it to be so that you have an understanding behind what the software is actually doing enough so that you can understand the process as well. So let's take a look. I made the scales on the vertical axis kind of separately from each other, just how I would have made them if I hadn't, made the graphs together. This is important to mention because the heights of these are a little bit different. So for example, my count of 5 ended up being 2 lines on my paper, and this corresponded to actually 10%. So these heights aren't exactly the same, and they very infrequently will be. What I would like you to notice, however, is that the shape of these is the same. So one is a little bit higher than the other. However, the overall shape will be exactly the same when you're making the same data in a frequency and then a relative frequency histogram. So another note is that my labels in the bottom axis have what my data represents, which in this case was test scores. I did do this by hand, so my the width of my bars is pretty close to being equal. But this is why we want to use software for something like this. We want them to be exactly the same width because 51 to 60 is exactly the same width as 61 to 70 and so on. So you want these to be something that you can compare directly because the width of those classes is the same. From this graph to the relative frequency, I did try to make them almost exactly identical. So while the vertical axis was a little bit different, we still ended up creating a graph. This one just ended up being stretched out vertically. If you would like more practice creating histograms, we will, as we go on through the rest of this unit, we will actually make a number more of them. So if you would like, eventually you will be able to make a histogram from our previous data using the software and then recreate that by hand. So there'll be a lot of other chances to make histograms. You will initially be responsible for making the histograms by hand, but eventually we want all of our histograms as well as our other graphs to be made using the software so they are nice and professional.